These two plants are close relatives, look similar enough to confuse experienced foragers, and one of them can kill you with under 1/10 of a gram, about 6 to 8 leaves. This is poison hemlock, next to wild carrot. Real poisoning deaths have happened from exactly this mix-up. Chamomile gets used as a common name for more than one distinct plant. German chamomile and Roman chamomile are both simply chamomile to most people, even though they're different species. Common names are also regional. The wild carrot from our cold open is also called Queen Anne's lace in many places. Same plant, different name, depending on where you are. They're fine for casual conversation. They are not precise enough for safety-critical identification. Every recognized plant has a two-part Latin name, genus, then species. Think of the genus as the broader group of close relatives, and the species as narrowing that down to one exact plant, not just a cousin. Take Conium maculatum, poison hemlock. Conium groups it with its closest relatives. Maculatum narrows that down to this one specific dangerous species. That name is globally standardized, unambiguous, and exactly what you should look for on a serious herbal product or reference, alongside the common name. Here's why families matter beyond naming. Related species often share related chemistry, sometimes helpful, sometimes dangerous. Poison hemlock, wild carrot, parsley, and celery are all in the same family, Apiaceae. That relatedness is exactly why they can look alike, and why foraging without confident identification is genuinely risky, not just theoretically risky. But shared family membership isn't a safety guarantee. Parsley and celery are edible members of that same family. Poison hemlock is not, and family membership doesn't make any of them interchangeable. Never identify a potentially dangerous plant from a single photo, one matching feature, or an app result alone. Confident identification means multiple confirmed features, not one. One more wrinkle. Even within a single species, different populations, called chemotypes, can produce meaningfully different chemical profiles depending on climate, soil, and genetics. That matters practically. Two batches with the identical botanical name can differ enough in dominant compounds to change the expected effect, the appropriate use, and the safety profile. The name gets you close, but it isn't the whole story. Still worth knowing the chemotype exists as a variable, especially for essential oils. Species, part, family, and now naming, the identification toolkit is nearly complete. Before using any plant, run a quick checklist. The botanical name, the plant family, the correct part used, the geographic source, the preparation or product identity, and whether the identification was independently verified, not just assumed. 6 checks, and most identification risk disappears. Next lesson, we go inside the plant, what active constituents actually are, and how they work together. Grab the workbook page. Look up the botanical names of 3 herbs you already use. See you in Lesson 9.